is this. Why can we not measure lines or rays? Garrett, why can we not measure lines or rays?
They go on forever, but I think for lines, because there's two rays going on opposite sides.
Okay, so what do you know?
They would go forever.
Exactly, we can't measure lines or rays because they both extend forever in at least one direction. Our rays extend forever in one direction. Like Garrett said, our lines extend forever in two directions. So we're not going to be talking in our class about how we can measure lines or rays because we can't. Okay, we're focused on segments. I don't remember if it was this class or another one of my geometry classes when you guys did your definitions in groups last time. My segment group said it's a line with a stop and a start. Or, yeah, stop and a start. Was that you guys? Yeah, I liked that, okay? All right, our segment addition postulate. This is going to look very familiar because you guys just spent about 10 to 15 minutes looking at this. Our segment addition postulate says, in general, if B is between A and C, then the following has to be true. The length of AB plus the length of BC has to be equal to the length of AC. Okay, and there's a visual for you. So if B is in between A and C, the length of AB plus the length of BC has to equal the length of the whole thing. You'll hear me say that the part, so AB, plus the second part equals the whole, okay? Alrighty, if you go straight down in that column, we have a couple of examples. The first example says to find the length of GH. It's always a good idea to kind of mark in a color what you are looking for. Find the length of GH. Griffin, how can we find the length of GH? Yep, subtract 9.7 from 15. And Griffin, do you have what that equals?
No.
Okay. Grace? 5.3. 5.3. Okay. That is just a very, very basic application of the segment addition postulate. The part and the part has to equal the whole. Okay? Let's ramp this up a little bit. Okay, let's ramp this up a little bit. Let's add some algebra in here. Find the value of x and the length of yz if y is between x and z. This is the first part that I want to deal with. When I see y is between x and z, first thing we should do is draw a picture, okay? Draw a picture. Y is somewhere in between x and z. The next pieces of information that you are given in this example, we are told that the length of xy is equal to 2x plus 1. I'm going to take that expression, I'm going to write it right above or below, whatever you prefer. Write that expression next to the segment that it represents. I'm going to do the same thing with the length of YZ. I'm going to take that 6x, I'll write it above segment YZ. And then finally, I'm told that XZ, so that's the entire segment. The entire segment is equal to 81. So we have an expression for the first part, we have an expression for the second part, we have a length for the whole thing. So using that segment addition postulate, Corbin, what do you think we can do here?
Y between X and Z,
Okay.
and 2X plus 1 plus 6X equals 81.
Very good. I like how you started with that first part of the segment addition postulate. If this is true, if y is between x and z, then this part plus this part has to equal the whole thing. Very good. From here, that's just a little algebra problem, okay? Let's combine like terms. The 2x and the 6x is 8x. So 8x plus 1 equals 81. Subtract the 1. Divide by 8. So the value of x is 10. So if you look back at the problem, it says to find the value of x. We've done that, but then it also asks us to find the length of yz. If I now know what the value of x is, how can we find the length of that segment? Jordan.
Multiply 6 by 10.
Exactly. If yz is equal to 6x, we can plug that 10 in for x, and the length of yz is 60. Very good. Let's look at the next example. It's going to look similar. The first part reads almost identical. Find the value of x and the length of KL if K is between J and L. So that information is the first thing I'll work with. Draw yourself a picture. K is between J and L. K is between J and L. From here, use those expressions for the 3 different segments we're given. Fill it in on your picture. It's going to be so important in geometry class that you guys are drawing a picture of the situation, filling in any information that you're given. So with that being said, JK is 2x. KL is x plus 2. Now this time, this is a little different. The length of the whole segment, JL, we're also given an expression for that as well. Okay. Anna, what can we do from here using those expressions? Very good. So she said the first part plus the second part has to equal the whole thing. Very good. And then again from here, just a little bit of algebra work. On the left-hand side, we can combine the 2x and the x. That's 3x. And then we can move all of the x's to one side, all of the constants to the other. So I'm going to do 2 steps in one. I'll subtract the 3x, and I'll also add the 10 to the other side. So we should have 12 equals 2x, and then x equals 6. Am I finished? Tyler, why not?
Because you can find the value of K, or the value of segment KL.
Okay, we need to find the length of KL, and Tyler, how can we do that?
You just plug in 6 to where the X is in KL.
Very good. And KL is x plus 2, so that would be 6 plus 2, which is 8. Alrighty. What does the word congruent mean? Do you know? Do you have an idea? Have you heard that word before?
Yeah.
Yeah, what does it mean?
Like similar.
Similar. In geometry, similar actually means something different than congruent. So like, what to you, what does similar mean?
Like the same.
The same. Same what? Same size. And shape. Very good. Next semester, we'll talk about what the word similar means in geometry because it does mean something different than congruent. Okay? To be congruent, that means the two figures are the same size and shape. Because we're talking about segments, congruent segments have the same length. They don't really have a shape. So if they're congruent, they just have the same length. Our symbol for congruent is an equal sign with a little tilde on top. Okay, that is our symbol for congruent. So if you see that, understand what that means. Okay, and I did kind of talk about this a little bit up on the board, but I want to talk about this one more time. We say that segments are congruent. Segments are congruent, meaning we would say that segment AB is congruent to segment CD. Segments are congruent. Segment AB is congruent to segment CD, but we say that their measures are equal. Their measures are equal. So the measure or the length of AB is equal to the length of CD. Notice when I'm talking about the segments themselves, I'm using the segment symbol. When I'm discussing their measures, I don't have that, okay? And I will remind you, like, every single day the difference between those, okay? The segments are congruent. Their measures are equal. All right, last two examples here, ladies and gentlemen. Number 1. Draw a sketch of the 3 collinear points, then write the segment addition postulate for the points. So we've had practice with this already. A is between T and Q. Draw yourself a sketch of that. A is between T and Q. And that point A, you guys can have anywhere. You tend to put it right in the middle, but that's okay. As long as it's in between T and Q. It can be anywhere. Then write the segment addition postulate for the points. So if you think back to the activity that we did, like number 3, where we said if B is between, that's what I'm looking for your segment addition postulate. So in this case, we would say if A is between T and Q, then what must be true? not T plus
no.
A.
Segment, or is it just TA?
TA, okay.
AQ equals TQ.
Very good. The first part plus the second part equals the whole. Very good. All right. I'm going to let you guys as a group do example number 2. When your group is finished, I want one person from your table to come find me, and I'll check your group's answers. Okay? So number 2, go.